Hello, everyone. Assalamu alaikum. Let's get started with this review of M1. So now let's focus our attention on the recent papers. 2024, I have solved some of them, but I am very much interested in the papers that is of 2023. So let me go to 2023 M1 papers and let's get started with a review of these. So now, if I look at the syllabus of M1, so when we focus on M1, there is kinematics. There are two kinds of kinematics. One is about constant acceleration, and the other one, it's about variable acceleration. So the constant acceleration portion, that is about what? Constant acceleration portion can be done based upon VT graphs. It can be done based upon equations of motion. And the variable acceleration, this is about differentiation and integration. So now that is one thing that is happening over here. And then we have a lot of things related with resolution of forces. It's about resultant. It's about equilibrium. And it's about horizontal surface. It's about inclined plane. And resolution is everywhere. It can involve F max is mu r. It can involve what you call F is equals to mass into acceleration. It involves equations of motion. And let me just write resolution over here. So let me take the word resolution. Let me write it over here. And basically, this whole thing is about forces. And along with forces comes another chapter that is Newton's laws of motion. So these two come collectively or separately. I mean, there is a whole variety of it. And what else is there? Then we have something like work, energy, and power. And then we have momentum, a new chapter that got started in 2020, and it's considered one of the tough chapters. What else is there? What about if we talk over here about connected particles, pulley systems, and so on? So let me go to this 2023 papers and let me pick few of them. Let me pick selected questions and let me go over it. So now over here, let's look at the first question about momentum. So let's get started with momentum. So first of all, over here, it says two particles P and Q of masses m and 0.3 kg respectively are at rest on a smooth horizontal plane. P is projected at a speed of 5 meters per second directly towards Q. So P is moving towards Q. And initially they are at rest. That means this was at rest. Now it's starting to move towards us. After P and Q collide, P moves with a speed of 2 meters per second in the same direction as it was originally moving. So I have a tendency of making things move to the right. And then it's moving in the same direction. Find in terms of m the speed of q after the collision. Mass, velocity or speed, mass, speed, mass, speed, mass, speed. So basically, Tm stands for total momentum, C stands for collision. Total momentum before collision is equal to total momentum after collision. So let me write over here, BC, that is before collision. And AC, that stands for after collision. This is called principle of conservation of linear momentum. Total momentum before collision is equal to total momentum after collision. The concept of momentum, the formula is very simple. Mass into speed plus mass into speed, mass into speed, mass into speed. So V comes out to be 10 meter per second. It is saying find in terms of M the speed of Q after the collision. So this is M into 2, this is 5M, and I think I missed out the M over here. So let me correct myself. It is 10, but this is 10 M meter per second. So I've done the correction. After this collision, Q moves directly towards the third particle R of mass 0.6 kg. So now the story of Q is there. It's moving towards R. It has a mass of 0.6 and which is at rest on the plane. Q is brought to rest in the collision with R. So Q comes to rest, R keeps on moving. Find the value of M. Again, now it's about these two particles. Total momentum before collision equals to total momentum after collision, and M comes out to be 0.3 kg. So now, since you have a paper a day after tomorrow, I would suggest that I uploaded a video in the morning. That is about Feb-March 2025, variant 42. There is only one variant in Feb-March. Do watch it out. Again, there was a concept of three particles, that is P, Q, and R, and the distances, I think, were 3 meter, 3 meter. And it's a very, very conceptual question. So do watch that in this particular video solution. So now this thing is done. Let me go to some other question, some other paper, and let me look at another collision question. So again, first have a look at this thing. So read the question first, something very obvious, but it is necessary that you focus on the question. So let me write some instructions over here. Read the question thoroughly. Not everyone does that, believe me. So now I hope that you have read it out. It says two particles A and B of mass 3.2 and 2.4 kg. Naturally, the masses should be in kg. The speed should be in meter per second. If, for example, they forgot to give in kg and give it in grams, make sure that you change it. They lie on a smooth horizontal table. A moves towards B with a speed of V and collides with B, and which is moving towards A. Now, this is not at rest. This is moving towards each other. So if you consider this direction to be positive, the other direction will be taken as negative. In the collision, the two particles comes to rest. Find the value of V. The next part. Now, there is kinetic energy also involved with this. So therefore, this question is about the basic concept of momentum, and it's also about kinetic energy only. Why only kinetic energy? Because it's a horizontal table. There is no change in height. So there cannot be any change in potential energy. All good, all clear? So now look at the working. Total momentum before collision equals to total momentum after collision. Let me just check my voice. Okay, this is all good. I was just checking on my phone. So now this is 3.2 into V, and this is 2.4 into negative 6, that is 0 plus 0. Therefore, V comes out to be 4.5 meter per second. Now it's asking about total, find the loss of kinetic energy of the system. So kinetic energy at A, that is half into 3.2 into 4.5 square. Half into 3.2 into 4.5 square. That is, this thing is 4.5. And this is half into 2.4 into negative 6. This is for particle A. This is for particle B. And when I add this up, that is the total loss because all the kinetic energy got wasted. So that is the second question that you see over here. Let me look at the third paper. There is also another question. Have a good look. two particles, P and Q. Why don't you read it and let me sip some tea? Now it says two particles, P and Q, of masses 0.1 kg and 0.4 kg, respectively, are free to move on a smooth horizontal plane. Particle P is projected with a speed of 4 moving towards Q, which is stationary. That means it is at rest. After P and Q collide, the speeds of P and Q are equal. Find the two possible values. So that's a nice question. So case one of the possibility is that they are moving in the same direction. So this is case number one. They both are moving in same direction. Case number two, the directions are reversed. So the one that is hitting, that has a tendency of turning back, and the other one will keep on moving forward. So first of all, over here, the velocities are equal. Total momentum before, after is the same. V comes out to be 0.8. The direction is reversed, this negative. So now V comes out to be 1/3. So I think 3 questions are good enough for this. Let me go back to the first one. Let me choose some questions related with energy. I can choose energy. Let me start with forces. Now, let me add a page so that you can have a good view of the diagram without this thing. And I think this first question is a tough one. So have a good look at this question, and then I'll show you the solution. So now momentum is done. Momentum tick mark done. Now let me focus on forces. So now it says coplanar forces. That means force acting on the same plane have magnitude such and such. So how many forces do you see? You see 4 forces, of which one of them is unknown and 2 angles are unknown. Actually, no, 1 angle is unknown because tangent of alpha is given. So let me draw a diagram over here. Something like this. When such is the scenario, so tangent of alpha, theta is not given, alpha is given. This is alpha. Tan of alpha is 4/3. This is 4. This is 3, 90 degree. This is 5. Therefore, sine of alpha is 4/5 and cos of alpha is 3/5. So these are the two things that you're getting. So now, first of all, it says that show that this thing is equal to 1. Now, the thing that strikes in my head is that an identity that is sine squared theta plus cos squared theta equals to 1. So somehow this is related to this. That's just a gut feeling. Second thing on the next page, I need the next page blank. So now over here, and that is the next page. Verify that. They're not making you solve. They are asking you to plug in and verify that P is equals to 6 satisfies this equation and find the value of theta. So now let's look at the working. First of all, look at the resolution of forces. Every single force needs to be resolved. Just look at the working, look at the triangle on the side, right side, look at the identity on the left. So now 15 Newton, focus on that. The force, the component, which is horizontal. Since the angle is with the horizontal component is always cos, always cos, always cosine, always cosine. And therefore, the vertical component is sine. What else is there? We have this thing. That means the original force is sandwiched between the components. The original force is sandwiched between components. Original force sandwiched between components. If I focus on the horizontal, horizontal to the right should equal horizontal to the left. Up and up should equal down and down. Now look at the working over here very, very carefully. So first of all, I am focusing on the horizontal thing. 15 cos alpha, 33 cos alpha, 30 cos theta, p cos theta, make cos theta the subject, because cos alpha is already known. That is right over here. Cos alpha is 3 over 5 for 0.6. Since they are working in decimals, therefore it is necessary on us to work in decimals. So I get cos theta. The next one is sine theta. Sine squared plus cos squared equals to 1. So I hope you like the question. A very conceptual question. And then over here, we plug in the value over here and we evaluate. We first verify, and sine theta is this thing, work in 2 decimal places, final answer 1 dp. So that is the kind of question that is we have done over here. Let me focus more on forces. Yes, this is another question. Let me add a page. First, look at it without any working shown over there. So forces, we are talking about what you call resolution. And we are talking about resultant. We can talk about it, resultant and equilibrium. These are the kind of things. And that is what is happening over here. So let me just write it, equilibrium. I think I missed out. So now over here, it says a particle of mass 0.6 kg is placed on a rough plane. So now we are talking about a rough plane, which is of 0.6 kg and inclined at an angle 35. The particle is kept in equilibrium by a horizontal force of magnitude P Newton acting in a vertical plane containing the line of greatest slope. Coefficient of friction is 0.4. Find the least possible value of P. Now, sometimes not everyone is sure which one would be the least and which one would be the greatest. So think of all the possibilities. First of all, this is P cos 35. Why? Because if this is 35, this is 35, this is the adjacent, this is P cos 35, this is P sine 35. And normal reaction force is this. 0.6 G sine 35 goes down, 0.6 G cosine 35 goes this way. Now, if it's about to move down, friction is up. If it's about to move up, friction is down. So think about it. So now there are 2 cases over here, and look at the working. Now, if I focus on this thing, F max as this one. So F max is down. This thing is down. Therefore, P cosine 35 is F max plus this. And if I focus on F max up, so P cos 35 plus F max is the weight component downwards. So this will give me the least possible value. Now remember this thing. Take a screenshot if you want to. If the particle is about to move up, that will give me greatest possible value of P. If it's about to move up, not only should it balance the weight component, it should also balance the F max. And if the particle is about to move down, it will give me the least possible value. So first of all, R is equals to P sine 35 plus 0.6 G cos 35. F max is mu R, that's the value of mu. P cos 35 plus F max is mg sine theta. Plug in F max over here, simplify, calculator, all these things, P comes out to be 1.41 Newton. So if you are watching in the comments, just let me know, is this question all good, all clear? Now, some involvement from your side is needed in the comment section. Okay, G, let's move on. So forces thing is done. Let me look for another forces kind of thing. Yes, this is the one. So let me add a page over here. And let me add a page over here. So now let's look at question number 7. Question number 7. It says two particles, P and Q, of masses 2 kg and 0.5 kg. So now over here, what are we interested in? We are dealing with an inclined plane. And then some distances are given over there. Looks like a tough question. Normally, question number 6 and question 7 are sometimes earlier also. These ones are tough. Two particles P and Q of masses 2 and 0.25 respectively are connected by a light inextensible string that passes over a fixed smooth pulley. Particle P is on an inclined plane at an angle 30 degrees. Particle Q hangs below the pulley. 3 points A, B, C lie on the line of greatest slope, and the distances are given. Particle P is released from rest at A with the string taut and slides down the plane. During the motion, Q does not reach the pulley. So the string is long enough, it does not reach the pulley. The part of the plane from A to B is tough. Coefficient of friction is given. B to C is smooth. Find the acceleration between A and B. Now, before I get started with this, let me first focus on this idea. That is this first paragraph, that is over here, that is over here. And naturally, this particular diagram, not only is it applicable for part 1, it's also applicable for part 2. It's also applicable for part 3. It's for part B, not 3. It's part B. It's applicable throughout. So now let's move on. So now after we have read this, they're asking for acceleration between A and B for 4 marks. That is the first part. Keep in mind, AB is rough. And then they're asking, hence find the speed of P at C. So once the particle is over here, now what is happening in this portion? We have to think about it. And then it says, find the time taken for P to travel from A to C. That's 4 marks. So 4 mark, 5 mark, that is 9 mark, and 9 mark plus 4, that is 13 mark altogether. So now let's look at the working. First of all, focus on the resolution. Focus on all the forces over here. The particles are there. Q has a mass of 0.25 kg. So therefore, we have this thing. Let me label it. The weight is acting down. Tension is acting up. Tension is acting up. The weight component, where is it? This thing. 2g sine 30. I did not label it over there because I labeled the distances. So 2g sine 30 is going down. R is going up. mg cos 30. 2g cos 30 is this way. Now, first thing first, the very first thing is find R. Whenever you are dealing, a lot of people, they forget this. Whenever you are dealing with friction, make sure you find R. So that is the first thing. So my bad. Let's open this up. Let me just adjust something. And I think it's all good. So now it says that first of all, focus on R. Let me increase the brightness a bit. So therefore, R is mg cos theta. M is 2, theta is 30. F max is mu R. Don't use the calculator at this point. Now let's move ahead. Find the acceleration. So now it's for each particle. Write down an equation related F is equals to ma. Mg sine theta minus F max. F max is acting the opposite direction. And mg sine theta minus F max minus tension is mass into acceleration. Mg sine theta minus tension minus F max is mass into acceleration. For this thing, tension is going up. Q is, the weight is going down. So there is no friction. There is no surface. Friction needs a surface. Tension minus mg is mass into acceleration. Add both the equations. You get the equation of the system. The T cancels out. and mg sine 30 minus this mg minus this F max is this total mass into acceleration. Acceleration comes out to be 1.02 meter per second square. Find the acceleration of P between A and B. So between A and B, the acceleration is found. Now, what is the next part? I think I've done that part over here. So let me just remove this page, which I have just used. That is this blank and removed. Okay. So now over here, it's asking, hence find the speed of P at C. So now over here, first find VB. That means the particle of the value of velocity of this particle at part B at 0.8 meter per second. 0.8 meters, not meter per second. It started from rest. That is the distance. That is the acceleration. So this we are doing for part B and C, and the time taken to cover the distance, because we are also looking for the time. So U is 0, S is there, A is there. I love using this equation. V square is U square plus 2AS. I find the velocity of V, and the time that I found, I'll use it later. But keep some space. That's why reading the whole question in such a scenario, it's very, very necessary. Now this thing is done. Hence find the speed of P at C. So now B and C, that is the smooth surface. The final velocity from the previous part becomes the initial velocity. Distance is 1.2. Now find a new acceleration. The acceleration will change. Why? Because it's a smooth surface. Mg sine theta minus tension is Ma. Tension minus Mg is Ma. A comes out to be 10 over 3. Using this thing, this U, this VB becomes this U. A is this new one, 10 over 3. S is 1.2. This comes out to be this. And the time taken for this path to cover this path, that is 0.547. The total time is the time calculated earlier, time this one, and that comes out to be 1.8 seconds. So there were three questions of different types that were related with forces. So this one, which we just saw, connected particle, let me just recap it for you. The first one was this thing that was about resolution and equilibrium. The second question was about this one. That was about this thing, the friction thing, the rough plane, inclined. And the third question was that. Now, focusing my attention on the same paper, it's a nice paper. And let me just remove some blank things over here. So over here, this is blank, this is blank. Let's remove it. And let's focus our attention to question number 1. What is question number 1? Read through it. What does it say? It says a particle of mass 1.6 kg is dropped from a height of 9 meters onto the above the horizontal ground. The speed of the particle at the instant before it hits the ground is 1.2 meter per second. Find the work done against resistance. So now this is about vertical thing, and it's about work energy principle. And we apply this concept that is total energy at the start minus total energy at the end is work done against resistance. Some people, they want to work this way. That is loss of kinetic and gain of potential, or vice versa. I personally prefer this thing. So initially, the kinetic energy is 0. Yes, it has potential energy. That is M into G into H. And when it moves down 9 meters, potential energy becomes 0 because we are measuring the height from this perspective. So potential energy at the base is 0. Kinetic energy is this thing. The difference between the two, it had more energy at the top. It lost some energy is left. So the lost energy is worked in against resistance. That is the answer for this particular part. So that is this one. Okay, let's move ahead. Question 2 was done. 3 was done. Question 4. Let's look at this question. It says an athlete of mass 84 kg is running on horizontal straight road. And it says initially the road is horizontal and he runs at a constant speed of 3 meters per second. The athlete produces power of 60 watts. Find the resistive force which acts on the athlete. So this is an application of F is equals to MA, and the F is obtained by this equation, power over speed. So power is 60, speed is 3, resistive forces are constant speed. That means acceleration is 0. It's right over here. So draw a diagram. Therefore, R comes out to be 20. That is the first thing. Now the next thing. Now again an inclined plane, but this time we are dealing with work, energy, and all these things. Now it says the athlete then runs up a 150-meter section of the road, which is inclined at 0.8 degrees, a very small inclination to the horizontal. The speed of the athlete at the start of the section is 3 meters per second. And he now produces a constant driving force of 24 Newton. The total resistive force which acts on the athlete is 13 Newton. Use an energy method. Find the speed of the athlete at the end of the 150-meter section of the road. And it's for how many marks? It's for 6 marks. The space is very less, but the marks are more. So because, very less working is required. Now, this is the concept in which sometimes an athlete is running, sometimes there is a cyclist, sometimes there is the engine of a car or a van or a motorcycle or a bike or an airplane. So the working is this thing, work done by the engine, by the athlete, that should equal to change in potential plus change in kinetic plus work done against resistance. The height is increasing, work change in potential is positive. The speed is increasing, change in kinetic is positive. Work done against resistance, we write it as positive on the right-hand side of the equation. And left-hand side of the equation, we write it as positive, work done by the athlete. So the work done by athlete, that is 24 Newton, force into distance, force into distance. The work done against resistance, that is 13 into 150. And the change in potential is mg sine theta into distance along the plane. Change in kinetic, half into 84 into v square minus 3 square. So v comes out to be this. And does it say, and he now produces at the start this thing, and then find the speed of the athlete at the end of the section of the road. Now over here, someone can ask this question, how do we know that the speed increases or decreases? Well, the chances are very high, and I played with that thing, that over here, what we are getting is that if this assumption was not true, I would be getting a negative value and I won't be able to take the square root. So if such a scenario occurs, go ahead and change the thing. So over here, since that person was exerting so much force, so the chances are very high chances that he will increase in speed. But it's not necessary. It could be a question sometimes in which it could give you a hint that the person slows down. Even though he's moving up, he could slow down. There is a possibility. So now this thing is coming out to be v squared minus 9 into this thing. This thing is coming out to be positive. Therefore, v is coming out to be greater than 9. Let's say if this was coming out to be negative, it should have been the other way around. So now this thing is done. I think that was the whole paper. No, the kinematics. Now let's focus on kinematics. So let me add a page over here. And there is also another page over here. And let me just do some adjustment first. So now if I just take this thing. Okay. So now let's focus on this. First, have a good look at the question. It says a particle P starts at rest, moves in a straight line from a point O, In other words, when t is 0, v is 0, s is 0, the first line says it all. At time t seconds after leaving O, the velocity is given by such and such, where b and c are constants. P has a velocity 8 when t is equals to 4, velocity 13.5 when t is equals to 9. So basically, the first part is simultaneous equation, and we will find b and c. Find the acceleration, differentiate velocity. So dv by dt is acceleration, plug in the value of 1. Find the positive value of t, and t has to be positive. When p is at instantaneous rest, that means v is equals to 0. Find the distance of p from O, that is the displacement at this instant. So you have to integrate velocity. Use the condition t is 0, s is 0 to find constant of integration. And then find the speed of p at the instant it returns to O. When it returns to O, displacement is 0. So nice comprehensive question. So let me now remove these two pages. Page 1, page 2, delete it. Okay, now focus on this. Just look at the working at every step. Some basic indices, I have done it on the sidelines that might be needed. This is the equation, equation 1, equation 2. Okay, it was needed over here. 4 raised to power of 3 over 2 is 8. 9 raised to power of 3 over 2 is 27. So let me highlight with the same color. So 9 raised to power of 3 over 2 is this thing. So that is 27 over here. And 4 raised to power of 3 over 2 is 8. And when we solve simultaneously, we get two answers. One of the answer is B is 3 and C is half. So they have made this a show question so that you don't waste the rest of the question. Even if you're stuck with this one, for some reason, you can skip it and use these values for later, for the next parts. It says find the acceleration when t is equals to 1. V is given. Differentiate, simplify, plug in t is equals to 1. This comes out to be 2/1/4. Now it says find the positive value of t when t is at instantaneous rest. So therefore, velocity equals to 0. And there is no constant, so you can play around by taking common. Maybe if there was a constant, it would become a disguised quadratic equation. But over here, this is easy. T is 0, that's the start. T is 36. That is when the particle is coming to rest. And what else is there? Find the distance of P from O. This is the velocity equation. You integrate, simplify everything. When T is 0, S is 0, therefore K is 0. I think they use the constant C. That's why I did not use C over there. So I used another constant. There are many alphabets in the English language. So K comes out to be 0. This is the displacement equation. Again, there is no constant. That is good. Take the variable common. And what else have I done? If I plug in t is equals to 36, S comes out to be 3 at 88.8. Alternatively, if I integrate between these two limits, because there was no other turning point in between, so you can go ahead and integrate it. I get the same answer without finding expression of S in terms of t, without evaluating constant of integration. But for this part, I need this equation. I need the displacement equation. So at the instant it returns to O, so S is 0, T is 0, that's the beginning. T comes out to be 56.25, plug that 56.25 in velocity equation, this comes out to be negative. They're asking for the speed, so speed is the magnitude only, and that's how this question is done. So that was a lot of questions from the first paper. Let me move to this paper. I think we talked about this thing, what you call momentum, from 3 questions. Now let me show you the working for this. So I think everything is going smoothly. And just have a good look at this question. Now there are some people who are asking this question. These are different 2023 M1 papers. Someone asked about S2 prep. Let me first send it. S2, it's tomorrow, the live session. S2 marathon is tomorrow. And someone is too impatient in asking question. People, when you're teaching something, I don't get distracted with the comments. Yes, I take my time and then I answer it. I hope that answers your question. So now this thing is there. It says a car of mass, this thing, that is over here, 1500 kg, is towing a trailer of this thing, mass M, along a straight horizontal road. And then it says the car and the trailer are connected by a tow bar, which is horizontal, light and rigid. That means it won't extend. The length will remain the same. Hooke's law or something like that won't apply. Light, ignore its weight. Horizontal, that means the forces, the tension in the bar, it would be just like this. And actually, it's like this. From the perspective of car and from the perspective of trailer, I'll just show you the solution. Then it says that there is a resistance force of F and there is a resistance force of 200. The driving force of the car's engine is this much. Acceleration of the car is this much. Tension in the tow bar is this much. Find the value of M and the value of F. So this one over here, that is May, June 2023, variant 43. So I'm just doing some papers at random. So now this is question number 2. Let me go up and tell you the solution. Now look at the solution. It says over here, that is, first of all, a diagram is a must. So that is the first thing that you should take care of. That is a diagram. That is the car. That is the trailer. These are the two resistive forces. That's red one is a tow bar. For the car, this tension it's given. That is an opposing force. For the trailer, it's a pulling force. It's moving forward with 1.25 meter per second square. Make an equation for car. Forward force minus tension minus resistive force is mass into acceleration. For the trailer, forward force minus resistive force is mass into acceleration. And then add both of them. Actually, you don't need to, because there is one unknown in each. So you don't need to make a single equation. From the blue equation, find F. From the green equation, find M. A small, beautiful, elegant question. I think I'll skip on this one. This looks like a nice question. Question number 4A. So let me first add a page so you can see it blank. Read the question. It says a lorry of mass 15,000 kg moves on a straight horizontal road in the direction from A to B. Now it passes A with speed of 20 meter per second and 25 meter per second respectively. The power of the lorry's engine is constant and there is a constant resistance to motion. The acceleration of the lorry at B is 0.5 times acceleration of the lorry at A. Now, this is not your traditional question, mainstream question. This is slightly different. Show that the power of the lorry's engine is 200 kilowatt and find the acceleration of the lorry when it's traveling at 20 for 5 marks. The lorry begins to ascend. Ascend means go up. A straight hill inclined at 1 degree to the horizontal. It is given that the power of the lorry's engine and the resistive force do not change. Find the steady speed up the hill that the lorry could maintain for 2 marks. So 5 and 2 is 7. Let's look at the solution. Look at all the underlining that I've done. I do believe in underlining. And this is, of course, my iPad. So I'm underlining in color. And that liberty you don't have in your paper. So make sure that when you underline, it has to be with pencil. That is the first thing. So now over here, first of all, acceleration at A is A, and acceleration at B is half of A. So that is the first thing that I pointed out. Let me point it out again. Let me highlight it. Acceleration of A is A, acceleration of B, it's half, that is half A. So that is the diagram. This is A, 20 meter per second. This is B, 25 meter per second. That's a very long line. So let it remain as it is. Okay, so now it says, make an equation for each. At this instant, power over speed minus resistive force is mass into acceleration. Power over speed at B minus resistive force is mass into acceleration. So it's a very, very nice question. Not difficult, but an elaborate one. Two unknowns, two equations. Simplify. You get P as 200 kilowatt. And you get A as 4 over 15 meter per second square. Got the idea? I made P the subject from both. I equated them. So let me use some greenish color over here. So over here, this is P equals to this thing. Over here, P equals to this thing. Now, these two things were equated. And then we find the value of A. And once you plug it in, you find the value of P. Now it says the lorry begins to ascend. And now when it's going up, what is happening? Let me just reduce the brightness. Once it's going up, that is the same power. We are looking for some steady speed. That means acceleration is 0. Resistive force is there and weight component is also there. mg sine theta. Theta is 1 and m is 15,000. So we get the value of V as 23.2 meter per second. So this is done. Let me just focus a little bit more. Yeah, this is a nice question. Very nice question. Okay, read the question right away. It says an elevator is pulled vertically up by a cable. The elevator accelerates at 0.4 meter per second square for first 5 seconds, then travels at a constant speed, then decelerates until it comes to rest. Find the greatest speed of the elevator, hence draw a VT graph, and so on. So I believe in drawing graphs first. So this is 0.4 and accelerates at 0.4 for 5 seconds. So this thing was unknown. That was V. So V over 5 is 0.4. Therefore, V is 2. And then it decelerates at 0.2 until it comes to rest. So now this is 2 divided by this difference is negative 0.2, or just use this thing. So 2 divided by 0.2 is T. T is 10 seconds. I just use the absolute value. So 30 plus 10, that is 40. And in between, there was a constant speed of 25. So that is 5 till 30. So first 5 seconds, then next 25, then next 10. Find the total distance. That is basic Kaddish stuff. That is area under the graph, area of trapezium. The mass of the elevator is 1200 kg. And now it's asking, there is a crate of mass m kg resting on the floor of the elevator. So that is the elevator. Given that the tension in the cable when the elevator is decelerating at this much, when the elevator is decelerating, the tension is this much. Find the value of m. So now, first of all, when we are talking about the elevator, we are talking about elevator plus this m. So therefore, this tension, is it going up? The mass is this thing, given the tension when the elevator is decelerating. I think it is going up, but decelerating. It's pulled vertically up. Again, this paragraph, it's for the whole question. So this is pulled up. Let me write over here. So this is pulled vertically up. And the acceleration is negative. But we will write the equation the way that I've taught my students in class. That is, the upward force is more, downward weight is less. That is equals to mass into acceleration. The negative sign will take care of it all. So this is the tension minus mg is equals to the whole m into acceleration. M comes out to be 50. So the mass of the elevator is 1200. The mass of the box is 50. Now let's look at this. Find the greatest magnitude of the force exerted on the crate by the floor of the elevator and state its direction. A very nice question. That is the crate. That is the floor. There is a normal reaction force. There is a weight. There are three possibilities. The first possibility is going up. All of them are going up, by the way. Acceleration and up, constant speed and up, decelerating and up. The left-hand side of each is the same, r minus 50g, r minus 50g, r minus 50g. Look at this, look at this, look at this. That is equals to mass into acceleration. Over here, acceleration is positive. Over here, acceleration is 0. Over here, acceleration is negative. This one is giving me the greatest value. If they would have asked for the least value, that is the answer. So a very, very nice question over here. This also looks very nice. Read the question. Question number 7, work, energy, power. And now over here, what does it say? The diagram shows the vertical cross-section XYZ of a rough slide. So it's a rough slide. The section YZ is a straight line. So this thing, I have shaded it. So this thing is a straight line over here. Let me highlight it for you. This is a straight line. Of length 2 meters, inclined at an angle alpha to the horizontal, where sine alpha is this thing. The section YZ is tangential to the curve. So that means this is tangent to this curve, 1.8 meter above the level of Y. So this is 1.8 meter above the level of Y. So now let me just highlight few other things. First of all, let me get an eraser. Okay, so now sine alpha is this over here. Let me remove this like this. Okay, so now this thing over here, that is the inclined thing. That is the curved portion over here. And it says it is tangential to the curved section and 1.8 meter above the level of Y. And then it says a child of mass 25 kg slides down. The slide starting from rest at X. So that is rest at X. The work done by the child against the resistive force is 50 joules. Find the speed of the child at Y. Now the concept is that total energy at X minus total energy at Y, that is equals to work done against resistance. Kinetic energy at X 0 because it started from rest. Potential energy, use the vertical height, mgh. Kinetic energy at Y, half into mass into V square. We are looking for the speed of child at this thing. Potential energy is 0 because that is the base level from which this height was measured. All good, all clear? So now over here, we find the value of V. The value of V is this much, rounded off value. If you use it for next part, use the unrounded value. It is given that the child comes to rest at Z. So where is Z? Z is this last part. So now we have the initial speed of the child. It's coming to rest. It's 2 meters. Does it say that this is rough? I think it is still rough. Yes, use an energy method. So don't use F is equals to ma. Don't use kinematics equation, constant acceleration equations of motion. Don't use that. Use an energy method to find the coefficient of friction between the child and YZ. Give your answer as a fraction in its simplest term for 6 marks. And that must be 4. Yeah. 4 and 6, 10 marks. Now over here, total energy at Y, that is kinetic energy at Y, and potential energy at Y with respect to this thing. So do we have the height? We don't have the height, but we can calculate it. Sine alpha is 0.28. This is 2 meters, so I can use this. Or I can write mg sine theta or sine alpha along multiplying with the distance. That's the same thing. So now this root 32, that was over here. So I just use the exact value for the next part. Not even this, the exact value. Because they're asking for a fraction, so decimals won't be helpful. So that is why I show every step along the way. Total energy at Y equals to work done against friction. Because over here, it's coming at rest. And the potential energy is 0. So the total energy at Y should equal work done against resistance. So this 540 is F max into 2. Find F max first. Then find the value of R. So that is the surface like this. The surface was this pinkish surface over here. So let me just draw the surface so that you have an idea what exactly am I doing. So now perpendicular to the surface, we have R. Got it? So this R is acting this way. This is mg cos alpha acting this way. F max is mu R, that is mu into this thing. Sine alpha is 0.28. Use identity, find cos alpha. So that is how I have used it. And then mu comes out to be a beautiful fraction, that is 9/8. Just a misconception with which very, very educated people also have. Mu is not probability. What do I mean by this? A lot of people, they have this misconception that mu lies between 0 and 1. So it's a misconception. Mu lies between 0 and 1. There is no such thing as this. Mu is positive for sure. Mu could be anything greater than 0. It's not a probability. Keep that in mind. So now this thing is done. Let me read a few things from the mark scheme, from the examiner report. And let's see if it's beneficial for you. Because a lot of people have all the knowledge of the world and they are not very good at applying it. So that is why this knowledge is a must. Okay, so now this is the mark scheme that you, the examiner report. I'm saying it over and over again. So exam reports, they are very, very useful. So now over here, it says key messages. It says non-exact numerical answers. Let me get the highlighter ready. Non-exact numerical answers are required correct to 3 significant figures. As stated on the question paper, candidates would be advised to carry out all working to at least 4 significant figures if a final answer is required to 3 SF. So very simple thing, but people forget. The next thing, when answering questions involving forces in equilibrium or Newton's second law or an energy approach, a complete force diagram can be helpful. They are not forcing it onto you, but they are saying can be helpful. I totally agree with this thing. All relevant terms are included in the equations form, and they are referring to those questions. In questions with a given answer, That means the proving one, where equations must be solved in order to find that answer. Candidates are advised not to use an equation solver on their calculator, since this does not explicitly show the given answer. Example, question 4A, question 5A, something like that, 5B, simultaneous or something. General comments. The paper provided the opportunity for all candidates to show their knowledge of the subject. That means always expect that there would be variety of questions. So there will be the easy ones, there will be moderate ones, and there will be some tough ones. Now, if you can handle the easy ones perfectly well, moderate ones perfectly well, and tough ones almost more than half, so then therefore you are fit for your A star or an A grade. More than half, that means you form the equation. Maybe you get stuck at one point, you come back to it later, and then you are all fit for this. Much work was of a very high standard, and these ones were challenging. In question 7, it says the angle was given exactly as sine alpha is 0.28. There is no need to evaluate the angle. Such as this, as any approximation of the angle can lead to loss of accuracy. So that means either you work with identity sine squared theta plus cos squared theta equals to 1. And in that case, cos theta comes out to be 0.96, or you work with a triangle to get the angle. For example, if sine of alpha is 0.28, let me work it out. So this is 28. 0.28 is 28 over 100. That is sine of alpha. So this is 28, this is 100. Now let me grab my calculator, and 28 square, not cube, that is a square, my bad. So that is coming out to be 784. 1, 2, 3, 4 zeros. 9216, and hold for a second, I got a negative sign, and let me take the square root. That comes out to be 96. So the base is coming out to be 96. Therefore, cosine of alpha is 96 over 100. We can also work it out like this. Got the idea? So I think that is pretty much about it. Basically, remember the wordings, remember the working, show all essential working. That is one thing. Your concepts should be very, very clear. Draw diagrams where needed. Work with clarity. Show all working, that is one thing. Working with clarity is the other thing. Think before you answer. And where possible, work in exact form, whether it's about fraction, whether it's about square root, whether it's not pure maths. Otherwise, I would have said pi. So work in exact form where needed. And I wish you all the best of luck for this exam. Take care, everyone.